In this video, we'll see how to convert numbers to proper scientific notation. What is proper? In scientific notation, we're only allowed to have a number between 1 and 9, but not 0, not 10. So the number has to be 1, 2, 3, 4, one digit up to 9, and a decimal. Behind the decimal can be any number of decimal points, but the first significant digit has to be a non-zero number between 1 and 9 included. The powers of 10 multiplied can be negative, 0, or positive, and they will depend now on the size of the number. So if it is a negative exponent, those are small numbers between 0 and 1. Multiplying by 10 to the 0 power is like multiplying by 1, so the number remains the same. That's a whole number. And then multiplying by 10 once, multiplied by 10 twice, or 3 or 4 times, becomes larger. So this is like the order least to greatest right there. In our examples, we are going to have numbers that are not in scientific notation. Like 48.6 is not one digit, you have 2 digits. So that is already not following the criteria of this scientific notation. So even though it appears to be like a scientific notation because it has a power of 10, this is not a one non-zero digit. So we have to make a conversion. There are a few different ways to do so. I'm going to move to standard and then convert back to scientific, and I'm going to show how to use the rules of exponents. So for example, I have 48.6 times 10 to the third power. How does that look like in standard form? In standard form, it is the number 48.6 multiplied by 10 3 times. So times 10 times 10 times 10, that is 486 with 2 zeros behind. So that is 48,600. In other words, every time you multiply by 10, the decimal moves to the right 1, 2, 3 times. So here, if I was to follow from the calculator, the decimal was behind 48, 1, 2, 3 times. To show that, I can start with my original expression that was given, 48.6, and then move the decimal 1, 2, 3 times to the right. That is what times 10 to the third power means. For every blank, we add another 0, and my standard form right now is 48600, which represents 48,600. That in scientific notation is 4 point, the decimal goes after the first significant digit, multiplied by 10 to the 4th power. So I have 40,000, so that is the power of 10 to the 4th, and the digits behind 4 are 8 and 6. So you can say, I need to place the decimal after the first non-zero number, that's 4, and then count how many digits are behind. 1, 2, 3, 4. That represents the power of 10, 4. Another way to write this number in scientific notation properly is use the rules of exponents. So here's when we focus on 4 as the first significant digit, so 48. And convert that into scientific notation. So that would be 4.8 and bring down the 6 times 10 to the first power. So 40 is, if I ignore the 6 for now, 48 is 4.8 times 10 to the first power. Then bring down the 10 to the third. And from here, use the rules of exponents. That's power of a product. If you multiply two bases that are identical, 10 and 10, we add the exponents 1 plus 3. So that will be 4.86 times 10 to the fourth power, which is the same as here. So the proper scientific notation has one digit, 4.86 times 10 to the fourth power. Which way you will prefer, we'll see after we see a few examples and you follow the pattern. I like to convert to standard first and then see in the standard form convert to scientific notation. Rules of exponents are another option. You'll see which one you like after you practice. So let's see here one more time. 205, it is not one digit. We have 205. In proper scientific notation, we need to have just one number. So first what I'm going to do is use the standard form. 205, so 205.1, and then times 10 two times 10 times 10. That is my standard form of the number. Multiplied by 10 two times, the decimal moved twice to the right. So let's see that on paper. 205.1 multiplied by 10 two times means move the decimal twice to the right. So that's what times 10 to the second power means. So the standard form of the number will be now 20510, which is 20,510. To convert that scientific notation, we need to place the decimal after the first number that it's not a 0, and then multiply by the power of 10. 1, 2, 3, 4. The last 0 we don't have to write, so we write all the digits that are up to the last 0. That one can be ignored. So in proper scientific notation, we have one non-zero digit, which is 2. 051 times 10 to the fourth power. That represents 20,000. So it's 2 and then 10,000. Let's check that. 2.051 multiplied by 10 to the fourth power will be 10,000, and that is the standard form of the number. To use the rules of exponents, I'm going to focus on the number 205 and convert that to scientific notation. So that would be 2.05 times 10 to the second power. So I must not forget the 1 here. Times, then here was the 200. So 200 is 10 to the second power. And I have to bring down the 10 to the second power from the original expression. So my 2.051 comes down, times, and then using the rules of exponents, we keep the base and add 2 plus 2, that will be fourth. And that is the same answer as I had before, but using the rules of exponents. So one option is to convert the number to standard form and then scientific notation. Another option is to convert to proper scientific notation using the rules of exponents. So we have 78.3 times 10 to the negative 4. Let's see what happens here. First, I want to see the number in standard form. 10 to the negative 4 means divide by 10 4 times. So if I use my calculator, 78.3, and I divide by 10 4 times. So I divide by 10 1, divide by 10 twice, divide by 10 again, and divide by 10 again. And see how the decimal moved now towards the left, because for every division the decimal is going to move left, 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 and for each digit we need to move to the left 4 times. And that, if I follow from the original problem, my decimal was behind 78, and then for every division 1, 2, 3, before the decimal moved to the left and the number became smaller and smaller. So I'm going to show that on the paper. First, I have to move my decimals to the left, so I'll write the number here, 78.3, and then 1, 2, 3, 4 times the decimal moves to the left. In the blanks, I fill in zeros, so my standard form of the number will be 0.00783, just like I had it right here. I can put the 0 in front, so it's 0 point, and then to standard, from standard to scientific, I need the first non-zero digit, that'll be 7.83, multiplied by a negative power of 10, because it's a small number, and after 7 we have the decimal, so it includes 1, 2, 3 digits. That would be power of negative 3. So we had our original number. I change it to standard form or its numerical value, and then I change it back to scientific. Using the rules of exponents, I'm going to focus on the number 78, and that it's 7.8 times 10 to the first power. Don't forget the 3. And then bring down my power of 10 from the previous line. So don't forget the 10 to the negative fourth. Here was the 78.3 converted to proper scientific notation, where the decimal is behind 190 number, so 7.83 times 10 to the first. Then, using the rules of exponents, I need to keep the base and add 1 plus negative 4. 1 plus negative 4 will be negative 3, which is the same exact answer as we had before. .3 times 10 to the fourth. Multiplying by 10 4 times to get to standard form. So 0.3 times 10 once times 10, 2 times 10, 3 times 10, 4 times. That is 3,000. So my decimal was here, and then I had to multiply it by 10 4 times. 1, 2, 3, 4. Let's see. Originally, 0.3 multiplied by 10 4 times means 1, 2, 3, 4 to the right. Decimal move, add a few zeros, and here's my number 3,000. 3,000 in scientific notation is 3 multiplied by 10 to the third power. The decimal goes after the significant digit. 1,000 is 3 to the 10 to the third power, sorry. This is my preferred way of converting to proper scientific notation, because I can see my standard number and then have it properly written in scientific notation. But I'll still go with the rules of exponents. Here we have 3 in the tens place. That means in proper scientific notation we have 3 times 10 to the negative first. Bring down 10 to the fourth. 3 remains, and here we have to use the rules of exponents, where we keep the base, and negative 1 plus 4 would be 3. Same answer. All right, let's see again. A decimal number, 0.2 hundredths, is multiplied by 10 to the negative 3. What if I do it backwards this time? I'm going to use the rules of exponents first and then a standard form. Let's see if that is an option that could work for you. So 2 is in the hundredths place. That means in scientific notation that is 2 times 10 to the negative 2. Bring down 10 to the negative 3. Then 2 we bring down and use the rules of powers. Keep the base at the exponents. That will be 2 to the negative 5. So in proper scientific notation, 2 times 10 to the negative 5. Here, I want to use the same example and convert to standard. To standard, division by 3 is moving the decimal to the left. So I'm going to write it here because I need space to move to the left. And then multiplying by -3 means go left 1, 2, 3 spaces. And my standard form is going to be 0.00002. I can put the 0 in front, which has now 1, 2, 3, 4, 5 digits behind the decimal. That is my negative exponent. All right, one more example for us to see. I have decimal number, so I'm going to use the first significant digit. I'm going to do the rule first. That would be 4.56 times 10 to the -1, because the first significant digit is in the 10th place, times 10 to the -5, bring down using the rules of exponents, 4.56, and then keep the base at the exponents. -1 plus -5 is -6. Going through the standard form, I have 0.456 multiplied by 10 to the -5 means go left 5 times. 1, 2, 3, 4, 5. So my standard form is going to have now 1, 2, 3, 4, 5 zeros. The 4, the 5, and the 6. To write that in scientific notation, I need the 4, which is the first non-zero number, and that's where I place the decimal. And then look how many digits I have. 1, 2, 3, 4, 5, 6. That will be the power of -6. 10 to the -6, which is the same answer as here. So which way you would prefer, using the rules of exponents or going to standard first and then to proper scientific notation, you choose.